How does the Amazon relate to the Sargasso problem? One of the strongest hypotheses about the origin of the massive Sargassum floods is the deforestation of the Amazon basin in Brazil. This is because the algae feeds on the excess nutrients present in the sea, released by fertilizer runoff into the Amazon River when it is deforested. All of this generates eutrophication, similar to when lakes turn green due to the presence of nutrients and therefore a large amount of algae, but in the case of Sargassum, it is a large-scale eutrophication, affecting the coasts of many Atlantic countries. In addition, another hypothesis that explains this Sargassum problem is climate change and all the factors it alters, such as ocean temperatures, currents, and winds. And at the same time, these two hypotheses complement each other, as it is known that Amazon deforestation is closely linked to climate change, since by releasing massive amounts of greenhouse gases, it leads to an increase in global Earth's temperature and triggers negative effects on ecosystems, such as melting of the poles, rising sea levels, ocean acidification, the emergence of extreme weather events, and species extinction. The interesting thing here is that this is an example of how everything is connected when we talk about the ecosystems present on our planet. That is, how can an action that occurs in the jungles of Brazil harm the coasts of the Caribbean? Even the beaches of a country somewhat far from Brazil, like Mexico. This being one of the countries that has received the largest amount of Sargassum since 2011, the maximum deposits in the Mexican Caribbean reached impressive levels in September 2015 and May 2018, with an average of 10,000 metric tons per day. That would be equivalent to approximately the weight of 70 blue whales, the largest animal on the planet, per day. The recurrence of Sargassum in Mexico may be due to its geographical location, since these algae are moved from the Atlantic Sargassum Belt, or Second Sargasso Sea, to the Caribbean region by the action of ocean currents and airflow. In conclusion, we can't cite a specific trigger, but the contribution of Brazilian territory is key. With Amazon deforestation, water washes and carries chemicals and soil into rivers. Nitrogen is a nutrient that Sargassum needs to survive, and the main sources of this element are agriculture, industry, and residual waste. Researchers at the University of South Florida showed that the use of agricultural fertilizers in Brazil increased 67% between 2011 and 2016. And its use remains high following the expansion of soy, corn, sugarcane, and coffee production. These are basic products for human consumption in many cities around the world. Everything is connected. Healthy rivers generate healthy oceans. This information is still under scientific debate, but everything points to a wealth of compelling information. Let us know what you think about this topic. We hope to count on your support by subscribing and sharing this and other videos we've made about the Sargassum problem.